What is calculus? I'm not telling you it's going to be easy. I'm telling you it's going to be worth it. So let's find out a little bit about calculus. Calculus is a branch of mathematics that deals with rates of change, like velocity and acceleration. What we know of calculus today began in the 17th century with Newton and Leibniz. And this is Newton, Sir Isaac Newton. He was knighted, that's why he's Sir. And he's British. And on the right-hand side, we have Gottlieb Leibniz. And he's German, so he wouldn't be a knight. Calculus deals primarily with limits, derivatives, and integrals. And by the end of the year, you'll know what each of those words means. How does calculus differ from pre-calculus? Well, in a nutshell, pre-calculus is static, while calculus is dynamic. What does that mean? So static is not changing. So the constraints that we're dealing with, the variables, they're not changing amounts. Constant slope, constant rate of change. Whereas calculus is dynamic, means things are changing. What's the purpose of calculus? Finding the slopes of curves. Calculating the area of irregular or complicated shapes. Justifying old formulas. Calculating complicated x-intercepts. Visualizing graphs. Finding the average value of a function. Calculating optimal values. In other words, let's say you have, you want to be able to put a liter of some substance into a container, but you don't want to spend too much money. You want to maximize your profits. So you want to spend the least amount possible on the materials to make that container. With calculus, we can find that out. You can find out exactly what shape, what size container you should use. Average rate of change and instantaneous rate of change. Average rate of change is change over time. Instantaneous rate of change, as the name sounds, is change at a moment. On the left, we have a regular math problem. The person is pushing the box up the incline. On the straight incline, the slope remains the same. Therefore, the force that must be used to push it up the hill remains static. On the curved incline, however, the slope does not remain the same. So the force changes and therefore is dynamic. The steeper the steeper the hill, the more work it's going to take. The more that person's going to have to push, more force they're going to have to use to get that box up the hill. If quantities are continually changing, we need calculus to study what's going on. Other examples of regular math versus calculus. Regular math problem. How long is the cable? Well, this is just Pythagorean theorem. We did that in geometry. 6 squared plus 8 squared equals, we'll call that C for cable, C squared. I think you can probably figure out that the length of C is going to be 10 blocks. But what about the problem on the right? How long is the cable? Well, now that cable's not a straight line. It's arced, it's changing. We would need calculus to solve that problem. Regular math problem. What's the roof's area? Right, so if we're calling this the roof, That's just two rectangles. And they look like they're the same. Right? So that area would just be 2 and then the base and the height of the rectangle. A calculus problem. What's the dome's area? All right, so now you see we have a more complicated problem. Right? We can't just take one measurement and be able to plug it into a formula. But with calculus, we can find that dome's area. And we'll do problems like that. A regular math problem. What's the volume of the cup? Right, that's just a cylinder. So the volume is going to be pi times radius squared times the height of the cylinder. Right? Just get your values and plug it in. Right? Not too complicated. But how about the volume of this cup? We see here that this shape of this cup can be represented, well, two of the cups anyway, together can be represented by this equation, y equals tangent x. And with calculus, we can find the volume of the cup. And it's really not that as complicated as it might seem, thanks to calculus. So calculus is my favorite class because of its practicality. Calculus is used to solve real-world problems. You'll need to learn tools to solve problems, but then we'll apply them too. There's no limit to the places the study of calculus can take you. Thanks for watching my video. Bye for now.